All right, good afternoon, everybody. So if you're watching this video, it is for the Unit 1 review for the 21-22 school year for Algebra 2. Just a breakdown of the exam itself, you are going to have 12 multiple choice questions. You'll have approximately 40 minutes to get those done, and then one free response. And 15 minutes to get that done. Just be forewarned, the free response itself actually has 5 parts to it. So while it is only one question, there's actually 5 parts that you're going to want to get ready for. So let's go ahead and get started. This first problem says to identify the interval, set notation, and written description of the inequality below. So when we're doing this, you'll recall that we want to make sure that we start off by reading this from left to right. So I see here on this left part that we're coming in from negative infinity, and we're stopping here at -3. So we can already start writing our interval notation. We know we're going to go from negative infinity, and we always start that with a parentheses, because we can never get to negative or positive infinity. And then it stops at -3, and we use a bracket because it's a closed point. Okay, so we'll meet this, or we're going from 5 to infinity. We see that with that arrow there. So our 5 here would start with a bracket, and we go to infinity, and that would be a parentheses. Okay. For our set notation, we would start the set where x such that x is less than or equal to -3, or x is greater than or equal to 5. Okay? And if we're doing the written description, this would be x such that x is less than or equal to -3, or greater than or equal to 5. And this would be that breakdown. So it's very important to be able to how to read those, all in interval, set, and written description. So this problem here is the exact same skill. You'll see there, though, that the numbers are a little different, and be warned, there's an open point. What does that mean as far as interval, set notation, and written description? So go ahead and pause the video here, work on this one. When you're ready to move on, go ahead and move on to the next problem. All right, so for this problem here, it's asking for the domain and range of the graph below. So you'll recall that domain is our x values. How far side to side are we going? So let's figure that out. When we see this graph here, we see that we're going to be going to the left forever in the negative infinity direction, right? And this way to the left for negative infinity. And in the right, we see that we're going to be going to the right infinity. So my domain would be from negative infinity to infinity, or we could say all real numbers. Our range is our y values. Okay, how far up and down do we go? We always start at the bottom. So when we look at this graph, we see that the lowest we go when we're reading the graph here is at -5. So we're going from -5, and we go up forever, and we'd be going up to infinity. We could also read that as y is greater than or equal to -5 in our set notation. And again, this needs to be in terms of y because we're talking about the range. Okay? So this is your problem here. You want to make sure that you do the exact same thing. You're going to want to pause this here, work on this on your Pear Deck, and you're going to analyze the domain, which is all the x values, and the range, which is all the y values. When you're done, go ahead and move on to the next problem. All right, so this is an interesting question. It says find f inverse of 3 of the given set. So there's a couple of definitions that we need to understand. F inverse means the inverse, which is the switch of x and y. So when we have this f inverse of 3, typically what we see is when we have a 3 within a function, that's usually an x. But in this case, because it's this f inverse, this value in here has to be our y. And it's our y again because it's what the value is switched. So if we label all these points x, y, x, y, x, y, x, y, I want to see where is y 3. Well, y is 3 only at this third point. And when f inverse of 3 happens, our x value, which is what we're looking for, is 4. So this would be our answer of 4. Typically what students will do is they'll get stuck and they'll see, oh, the input is 3, so x is 3. And that would be true if this was just the function. This is not just the function, it is actually the inverse function. So our input is not x, it is y. Okay, if you have any questions, please message me on Teams or ask me during class instruction, guys. But let's go ahead and move on to the next one. So this is your problem. Same skills. So what are you looking for the inverse function of 3? That 3, are we talking about x or y? Okay, go ahead and take the time or write out your responses. Pause the video as needed. So let's do this one together. This is dealing with functions. Now, functions, we know we have some type of input and some type of output. So these A here would be our input and output. And we know with functions, functions are relations, right? So a relation would be a set of given points. But the function takes that a step further, and we know that our input values have to map uniquely to our output values. So if you know our input, we should get a specific answer for our output. Not several answers, but a specific. So let's look at this first example. Let's look at example number 1. I'm going to go ahead and number this here. Example number 1 says, date of getting a driver's license. So we know the date of getting a driver's license. Let's use an upcoming date, actually our test date of August 30th, 2021. If we know that date, could we pinpoint an exact person that got their driver's license that day? No, that would be impossible. We get a whole spread of people that got their driver's license that day, but not a specific. So I'm going to write here, not specific. So is this a function? Not a function. It's impossible. Okay. Number 2 here. So fishing contest participants. So if we know all the people participating in a fishing tournament, that's pretty much what this is saying. So we have a listing of all the fishing tournament participants. Can we know the number of fish caught? Okay, can we know that? If we know all the fishing participants, will we know the number of fish caught? Well, this is a little bit more specific, but I would say it's still not specific. We just know the participants, but we don't know how many they caught. If they said number of fish caught per participant, well then we could know all the number of fish caught in the tournament. So this would be not a function. Okay, make sure I spell function correct there. Let's do zip code. So like the zip code of the school is 78521. These zip codes are specific for the state. So knowing any zip code, if I said like 78521, 78520, 78526, those are specific for every state. And actually there, we could actually break it down even by city. So this is super specific. So because it's very specific, this would be a function. Okay. So now for number 4, I want you guys to do this one. If you know the age of the tree, if I tell you this tree is 30 years old, can you tell me exactly what type of tree that is? Think about that. For number 5 here, if I tell you exactly what type of bird, like if I said seagull or crow or pigeon, could you tell me what month the bird migrates? Think about that one. That one's an interesting one. And then lastly, number 6. If I tell you the number of days in a month, if I said 30, 31, or in the case of February, 28, could you tell me what person belongs to that month? Is that specific enough? So I want you to really dig deep into 4, 5, and 6. If you have any questions, please don't hesitate to ask. So let's look at this one here. I really like this problem. We discussed functions, but this is really pushing it to where they're already giving us calculations. And more importantly, we're doing a composite function. So they want us to solve for k of 0 if kx is the composite of f and g of x. So when we talk composites, okay, we know here that we can solve for these values. And we want to break this down. We know that this is our output, f would be our output, and g here is our input. So we want to start from the inside and work our way out. So check this out. I'm going to say f of g of 0. So when our x value here is 0, okay, so I'm going to start this in red. X is 0. What is, and let's change colors here, what is g of 0? Well, g of 0 here is 1. Do you see that there? When x is 0, g of 0 is 1. So what that means now is our new input is 1. Okay, this g of 0, and I write this out here, g of 0 is equal to 1. And this is our new input into our final output of f. So what is f of 1? Well, when I look here, f of 1, and I'm going to circle that in blue, our output of f of 1 is 0. So this would be 0. In other words, f of 1 is 0. So it's all about following the table. We could do this for all sorts of inputs, but kind of let this sink in, follow the pattern. So again, x of 0 was given to us. This is given. And we plug that into g of x. So when x is 0, our output is 1. That 1 becomes our new input into f of x. And when x is 1 for f of x, we get 0. Please, if at any time you have any questions, I can walk you through other examples given this table. Now I want you to solve for this one. What is k of 1? So you're going to do the same thing, and I'll even help get you started. We would see this as f of g of 1. So hint, hint, start from the inside. Okay, start from the inside and work outward. Inside, out. Okay. Follow the steps. Hint, hint, your starting x is here at 1. So what is g of 1? Okay. Work through this, pause the video as needed, ask me any and all questions. I'm here to help. So let's look at this one here. Determine which graph represents the function and its inverse. So I'll tell you this right now, there are 3 graphs here. Only one of these has an inverse. And the way we can check inverse is they have to be symmetric, okay, about y equals x. That is that perfect diagonal. So I'm going to draw a red line. that represents y equals x. Here's y equals x. If I was to fold on this red line, would my green and my blue perfectly land on each other? I'm going to say no. This is wrong. Those would not land on each other at all. What about the second one? I look at my y equals x line. If I was to fold on this red line, my blue here and my green would map. This one and this one would also map. This would be a yes, inverses of each other. And lastly, if I draw my y equals x here, and if I fold it, would the blue and the green land around each other? This is a no. It's a big fat X. So the only one here would be the one in the middle. Okay, easy skill, but it's also easy to mess up. Let's move on. So next we have some function manipulation and operations. So what's happening here is we're seeing f divided by g. F divided by g. What this means is we take that f of x over the g of x. Well, f of x is given to us as 4x minus 3 divided by g of x, which is x plus 1. What we want to do next is we want to make sure that we plug in our x value. In this case, it would be -1. So when we do that, we have 4 times -1 minus 3 over -1 plus 1. When we work this out, 4 times -1 is -4 minus 3 over -1 plus 1 is 0. So we get -4 minus 3 is -7 over 0. Now -7 over 0, I want you to put this into Desmos, your calculator on your phone, the calculator on the computer. There's an issue here. Because of this, because we are dividing by 0, this is undefined. We cannot divide by 0. If it was 0 divided by -7, that would work. But in this case, it is 0. That is the divisor, which is -7 divided by 0, which is undefined. Okay. Let's go ahead and move on to your problem. We have the exact same thing. I'll help get you started. This is f divided by g, so f over g, which is equal to 3x over x squared minus 4. So what you need to do here is you need to plug in our given value, substitute our given value of x equals 2, and determine what is the final answer to this. Okay? If you have any questions, please let me know, and I'll be more than happy to help you out. Let's go ahead and move on. All right, so we have a little bit more of a complicated issue here. It says, given the equations below, solve for what's happening here, which is interesting. So what's happening, and we'll write this out, it says 2 times f plus g minus 3 times f minus g of x. So this is direct substitution. Our f value, okay, when we're working this out is, and I'll put it in parentheses, x plus 2. That is f. G in this case, and we're going to do plus, is x plus 1. We close that up. Minus 3 times f, again, is x plus 2. Minus g, which is x minus 1. And we solve. So let's look here at the first part where we have 2. And we can start combining like terms because we see that we have x plus 2 plus x plus 1. And we'll just kind of clean this up a little bit. Minus 3 times x plus 2. Now, I can't just drop this last set of parentheses because I need to distribute this negative. And this would be minus x minus 1. We close that. Let's go ahead and start combining like terms. We have x and x, 2 and 1. So we'd say 2 times x plus x is 2x, 2 plus 1 is 3. minus 3 times x minus x. Well, those simplify out. And then 2 minus 1 is 1. So this is cleaning up pretty nicely. What we need to do here is then distribute this 2. 2 times 2x is 4x. 2 times 3 is 6. And then we have minus 3 times 1, which would just be minus 3. So lastly, we have our last bit of combining of like terms. And we're left with 4x. 6 minus 3 is 3. And this is it. So quite a bit of work. I know we didn't cover too much of this in class. We will spend some time later during this time of review to work on these function operations, whether we're adding, subtracting, multiplying, or dividing functions. But go ahead and go through the steps here. It's primarily substitution, distribution, and combination of like terms, combining of like terms. Okay. So now you have a very similar problem here, a lot of the same operations, but different inputs. So different F's and different G's. So go ahead and set this up and slowly start working it out. If you have any questions, please let me know. All right, our next operation here says to do FF of X. Well, FF, in other words, this is really just F times F of X. So we don't even need this G value, because what we're doing is we're just multiplying F. So when we do that, our first F is X plus 2 times X plus 2. When we're multiplying binomials, you'll remember from Algebra 1, we got to set up our box method. Okay, so we'd have X plus 2 times X plus 2. X times X is X squared. X times 2 is 2X. X times 2 is 2X. And 2 times 2 is 4. And we want to make sure that we combine these like terms here. So when we start pulling these values out, we're going to get X squared. 2X plus 2X is 4X plus 4. So when we see this here, in this case, we just had to box method this. We'll do more of this when we talk about quadratics, but it's understanding the multiplication of the functions that I want to stamp there. Again, we will do more of this function operations during the review and in upcoming lessons, but this is an important skill from Algebra 1 that's going to be tested on your exam. Okay? So let's go ahead and move on. This is your question here. Same skills, we're multiplying the function of f times the function of f. This is just like the previous problem. If you need to go back and review it, go ahead. If not, get started on this one, pause the video, and work through it. Ask me any questions as needed. Let's go ahead and move on. So we have this graph. We haven't really talked about these types of functions yet, but I want you to understand certain properties. It says to identify the x-intercept, the y-intercept, domain, and range. Well, what we haven't seen here is for our x-intercept, this is where we cross the x-axis. So I'm going to color in a blue line over our x-intercept here. And what we don't see is we don't see the red line cross this. So there is no x-intercept. So we're going to say no x-intercept. For our y-intercept, I'm going to color this in purple. As the red lines go forever up and down, they will get real close to the purple line, but they'll never touch. So for that y-intercept, there is no y-intercept. What about the domain and the range? So domain is our x values, right? So how far to the left and right? Well, this red line is going forever to negative infinity. And it comes in, it comes in, it comes in, and it gets really close to 0, but then it doesn't touch it. So when we see that part, we're going from negative infinity to 0. And we're going to use a parentheses here because, like I said, we get real close to 0, but we never touch 0. Okay, and then when we go continue on, we see how we're coming in here at the top, and we go on forever to the right. So we start at 0, and we go on to infinity forever. And you'll see here parentheses everywhere across, because while we approach 0, we never touch 0, and we can never touch negative infinity or infinity. As far as the range, this is a lot of the same issues. We start from the bottom, and we see here we're at negative infinity, and when we go up, we get real close to 0, but we'll never touch it. So we'll go from negative infinity to 0, and then we start at 0, and as we go up, we'll approach positive infinity, but we'll never touch it. So this is really interesting, and it's really breaking down that skills of domain and range. But we'll discuss this further in later classes, but it's important. This is a skill that I want to make sure that we have ready for your exam. So now I want you guys to apply that here. Domain, I'll give you a hint, is very similar to the last problem. I want you to understand why though. X and Y intercepts, well, hint, very similar, but I want you to explore, do we have X intercepts? Yes or no. Do we have a Y intercept? Yes or no. How do you know? And then the range, okay, domain and range, and then I skipped to the domain earlier, but domain and range, how far to the left and right? This is very similar to the last one. And the range, not the same. The range is actually going to start, it's not going to be from negative infinity to infinity, so just be ready for that. Make sure that you analyze this problem. Please ask me for help on any of these that you need help on. Let's move on. So here I want you to identify the X and Y intercepts for the function below. So this was a beginning skill. When we're looking for the X intercept, we want to set Y equal to 0, okay? So that when we do that, we're going to have 4x minus 0 equals 8. We then solve this out. We get 4x equals 8. We divide by 4, and we get x equals 2. When y equals 0. So our point here, our x-intercept, is at 2, 0. Our y-intercept, we need to set x equal to 0. So when we do that, we get 4 times 0 minus y equals 8. And 4 times 0 is 0, minus y equals 8. So then we get negative y equals 8. Divide both sides by negative 1, because we're not looking for negative y, we're looking for a positive y. And we get y equals negative 8. And this happens when x equals 0. So we have our y-intercept equal to 0, negative 8. And here's one answer, and our other one. Important skills, this is one that we did specifically, we spent the whole day on, so I want to make sure that you guys are very versed in this one. Now it's your turn. You're going to do the exact same thing. And so to get that x-intercept, you're going to set y equal to 0. To get the y-intercept, you're going to set x equal to 0. Give this a shot. Take your time. If you have any questions, please let me know. And our last set here, we're given what's known as piecewise functions here and our ability to analyze these graphs, okay? When we're looking at these here, we want to identify the domain and the range and any maximums or minimums. So wow, we have like, if you see it here with the red, it's like one part of a function. The blue here is another part of the function. And the green here is another part of the function. So when we're reading this, okay, when we're reading this across here, you'll notice that it's got like different domains and ranges. So when we're looking at this, we want to see where are we coming in from here on the left. So let's do our domain. Well, we're coming in from negative infinity. Okay, so we're going from negative infinity, and it goes to negative 2, and it keeps going all the way to 2 here. And we have this jump here. Okay, we have this jump, but while there's a jump, I want to make it very clear that that value here at 1, okay, this would be at 1, still exists. So we're really going, and we can break this down from negative infinity to negative 2, and we include that negative 2. Okay, we're also going from negative 2 to 1, and then we have that jump from 1 to, and it goes forever in the right to infinity. Now, this is nice, but what I want to make sure that you guys understand, even though we have all these jumps, this point at negative 2 exists and this 1. So we could say that our domain is actually every single number on the x value on the number line, because there's no holes. So to identify that, we would also say that our domain goes from negative infinity to infinity because all x values exist. For our range, and I won't make that as complicated, but our range here is from how bottom, the lowest we go, to the top. So the lowest we go, well, we're coming in from negative infinity, and it's going up, 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 and then it kind of stops here at 2, but it doesn't really stop here at 2, because you'll see here it kind of jumps over, and it goes up to this value of 5. So it goes from negative infinity to 5. And that's important. Okay? As far as mins and maxes, our max is our highest point. I'm going to put that in green here, which would be at 0, 5. And there is no minimum as the graph goes forever down. A lot got covered here. Okay, a lot. So I should expect a lot of y'all to ask questions during class or send me messages on Teams. But I want you guys to analyze the next slide. This is yours. A lot of the same skills. Hint, hint. Okay, go through the domain, go through the range. Are there any maximums? Are there any minimums? Identify them. I'm going to be checking this work here on your Pear Deck, and I want to discuss this in class as well. Okay, so if there are no other questions, keep working on this video. If you do have any questions, please let me know. We've got several days to get ready for this exam that I want you guys to do well on. Y'all have a good rest of the day, and we'll see you all later. Thank you guys.